Section 2.5 Misleading Graphs. In statistics, sometimes you come across graphs that they mislead the reader in a way that they try to convey information to them to convince them about good results, but probably in fact they are not that good. So that's called misleading graphs. So for example, if you look on the left side of the screen, part B, that's the actual graph of unemployment rate percent wise, and so that's in it was collected month by month. So the first one, September, as for September, October, November, December, and so on and so forth. And you see that the unemployment rate from the original data was given almost at the same rate. As you can see, it's very tiny, like between 7 and 8%. And what happened is someone cut part of the graph of part of the let's say not the graph but the axis. Some people cut the horizontal axis, sometimes cut the vertical, mostly the vertical axis. So they cut off part of the vertical axis, and notice what happened. Now the graph on the left side, which is A, it starts at 7, not 0 anymore. So it goes 7 to 8. Now what happened to the bars? They're not almost at the same level. For example, look at the last two bars, the highlighted ones. And on the right hand side, they were like differ by a tiny percent. But on the left side, there's a big difference. Even January, February, the one I highlighted, January, February, and both of them, compare them. Do you see what happened? When they cut off part of the axis, the vertical axis, that created a misleading graph. So people who are going to read the graph on the right side are not going to think about it the same way as if they read the one on the left side. So if you give two different pieces of paper and each one contains these two graphs and show it to somebody, they will tell you, oh wow, there's a difference between, in the figure on the left side, difference between the, let's say, January and February comparing to the one on the right side. Right side's almost the same, or February, March, they're almost the same, but February, March on the left, they're not the same. So this cutoff is called in statistics a truncated graph. So what is a truncated graph? I defined it on the right side. A truncated graph is a graph where part of one of the axes has been cut off or truncated. In a bar graph, like the one on the left side, this truncation causes the bars to cut off proportional and hence creates a misleading impression to the reader. The vertical axis always must start at 0. But if it, in this case, it starts at 7 instead of 0. So the part from 0 to 7 is cut off. That's how we say it. Now, why do people do this? Again, it's to mislead you, to get you to believe that there's really a big difference in this data and that data, or there's a big difference, or there's a great improvement in this study, or anything they like to get you to believe in. In general, it may allow relevant information to be conveyed more easily to other people. So that's why they do it in general. Is there a way to fix it? Yes. If the graph is truncated, we try to fix this. We start the graph at 0 instead of 7 or whatever it was, and include a special symbol on that vertical axis, such as like slashes, to indicate that that part is missing. That part from 0 to 7 is missing. So for example, if we have something like this on the left side, here we have 3 classes, class A, B, and C, and then notice how the number of students starts at 20, 30, 40, 50. What about if the number of students in a class is 5 or 7 or 12? It's not even 20, so, or more than 20. So that's a misleading graph that gets you to believe that, wow, this class has so many students. But if we would like to fix it, as I drew the graph on the right side, the way we do that is from 0 to 20, I redraw that part, and then I put 2 slashes to indicate that that part here was cut off in the original case. So that will fix the graph. Um, another example, sometimes let's say like a college or somebody would look at the transfer rates of ABC community college in general. And what happened is on the left side, you notice ABC college comparing to all the colleges in California, and look at the transfer rate. That might sound like, okay, well, the transfer rate in ABC college is 35%, but overall the average in all the colleges in California is 40%. So to make sure that that college is going to make the result look fancier than comparing to other colleges, so they truncated the graph. And they start at 8 instead of 0. And then the graph might look better here because from 35 to 24, the percent went down, but their goal was to take the result instead of 35 to 40, it went down from, it's much better now, it's 24 to 21%. So this means they are looking at it here in a way to show other colleges that our transfer rate is better than yours. That's what it is. This is just a random example. It could be any other data anybody like collected about anything, and it would run the same way when we truncate the graph. Overall, this example is a matter of comparing two different results, or two results, or even three results. You can have 3 bars next to each other. So that's what this is about. Another thing good to know is to recall that the area of a circle, you might need on one of the homework problems. The area of the circle is given by pi times r squared. R is the radius, and pi we already know is 3.14. That's the formula for the area of the circle to find its area. Now if we have two circles like this, the first small one has radius small r and the other one is capital R, and so the new one, they would tell you in the problem that the new one is twice as big as the old one area wise. That's what as big as the old one area wise. Then this means the area of the bigger circle, which is pi capital R square, is 2 pi small r square. You can cancel the pi's by dividing by pi. That will give capital R square is 2 small r square. And then we can do square root both sides to solve for capital R. You can take the small r square out. That will leave square root of 2 inside. So now, based on the given information, they said that the new circle is twice as big as the other one. Radius wise, this tells me that the capital R is square root of 2 times small r. It's not always, people might think, oh, it's big, twice as big. This means the radius will be twice as the small one, or 4 times. No. So this is again comparing two different things here. You might need it in one of the questions. The most important part is about what is a misleading graph and how do we deal with it. Now, last thing, they said the number of homes this year will be double last year. So what the developer did, they drew the actual house, which is this one, and then they tried to show the reader what happens if we double this. So instead of doubling size-wise and get something like this one down here, they went ahead and they doubled the length and the width of this house. And what happened is when you cut it in the middle vertically and horizontally, you notice that the new house looks 4 times as big as the one. It's not as double. It's not double. So that's a misleading graph. This is a misleading graph. So this is important. So back down to the circle, if we say area-wise, if I double the radius of the circle, the small circle, and becomes capital R, what happens? So in general, if you have small r is 3, and I want to double it, so capital R becomes 6. That doesn't mean the area of the circle, the area of the new circle will be double the area of the small circle. So for the small circle, if we calculate the area, that would give us pi r square, which is pi times 3 square, so 9 pi. But the area of the large circle, the larger circle, let's say, the area is pi capital R square. pi times 6 squared. So that's 36 pi. So people think, okay, this is 3, the radius is double. Now this means I'm gonna, the big circle will be as twice as big as that. That's not true, because the area covers everything. That's not true. Notice if you compare this area and this area, the 36 pi is 4 times 9 pi, right? So it's 4 times bigger. 4 times, not double. So this can also be a misleading information for people when they're reading something like this.